Well, good evening, everyone. Welcome to the live chat. We have quite a bit to talk about. First of all, of course, let's make sure that you can hear me. Everything's good. Looks like everything's running properly. Everything's working on YouTube. Look at that. Beautiful. And we have 31 and growing. We have several people joining already. We have an active, and we have the coffee. And we have an active chat room already. So, let's see. What's happened since we last chat? Well, we've had several winter canceled, winter not canceled, winter canceled, warm torch, cold torch, all the torches, right? It's that wonderful time of year where everyone is just a little bit too sensitive with the model guidance coming out. Now, we talked about beforehand that as this pattern evolves, you're going to get all sorts of crazy model solutions. And you're going to get some guidance that will produce blizzards 7 days out. Other guidance that will produce warm weather and temperatures in the 60s for several days in a row. And none of them will be correct. And what's happening here is that we're starting to see all the changes starting to take shape, but there's so much chaos in the atmosphere at not just the stratospheric level, but at the tropospheric level, even boundary layer conditions. And because of those different interactions, and you have two active jet streams, it just creates so much chaos that you have to look at each model guidance and say to yourself, does this make sense based on what we know? And is there any errors that are developing that doesn't make much sense? So, for example, yesterday, the 12Z guidance yesterday, even the European guidance, try to phase a shortwave that's going to be marching through the country early next week. Try to phase every shortwave in North America into one huge upper level low. Now, while I agree with the idea of a long range trough, and we'll take a look at that, the phasing of all the shortwaves into one massive low, which would lead to a massive warm up on the East Coast as a result, really doesn't happen all that often. It's very, very rare, and it typically leads to a huge error in the model guidance and basically a lot of convective feedback error. So when you see this, the first thing you should do is stop before making any changes to your forecast and ask yourself, is the pattern in the Pacific and the Atlantic supportive to phase all the short waves in North America into one huge upper level low centered right around the northern Great Lakes or northwestern Great Lakes? And the answer is no. We know this. We understand the pattern that's in place. And so as a result, we take that model guidance, we lift it up, we look at it, and then we fold it nicely, we put it in a trash can, and we light it on fire and throw it away because it is trash. And so you don't change your forecast. Instead, you wait and you say, let's figure out what is actually evolving here. So we look at our upper level winds. And we see what's taking place here. The polar jet stream remains incredibly amplified. And we're starting to see changes already taking shape in the Pacific. I.e., this trough is starting to get lifted out. Heights are starting to rise. This ridge is starting to move. This trough is getting deeper. Changes are on the way. So this would suggest that we're starting to see the indications of a negative EPO pattern. But there's even a better way to find out that that is the case. And you don't have to worry about the model guidance and the ensembles and the charts and all that stuff. I'm going to show you real simple. is if I click on the right one here. I always mess this up. Here we are. Okay, you don't need any of that model. I mean, it's good to use, don't get me wrong, but you don't need any of that to find out whether or not it's a realistic solution. All you need to do is keep an eye on this area. If you continue to see convection firing and shortwaves becoming enhanced, especially to the southwest of Hawaii, you know, based on research, what this does to the atmosphere. It amplifies the subtropical jet stream, it amplifies the polar jet stream, and sets up a higher threat for a trough around the Aleutians. This signal also, 10 to 15 days later, supports East Coast cyclogenesis. It is the precursor. It's the observational support. So if you see this, then you know what is realistic in model solutions and what is not. And by using this bellwether, you're able to look at model guidance and not overreact when you know there's going to be a lot of high-level volatility. And so, as we take a look at our water vapor satellite picture, you can see the changes taking place here. You could see the southeast ridge being displaced. Look where the strongest sinking air is taking shape. It's heading further and further west and getting crushed and weakened by our subtropical jet stream. You're seeing support for a little bit more troughiness on the east coast. Hasn't fully displaced yet, but you can see the process beginning. Oh, by the way, we have a storm out here in the Atlantic. NHC is trying to say it's going to become a subtropical storm. Maybe. They literally put a 50% chance on it, which means they're like, we don't know. 50-50. Throw a dice, see what happens. What really is going on here is that you can tell that it's still a extratropical storm, but it's trying to produce a warm seclusion here. You see this a lot with major cyclones in the winter. So it's not a pure subtropical low, but I wouldn't be surprised if they try to designate it as such. But when you have this signal here, that's clearly cold core. In other words, it's being driven by baroclinic forces. All right, so it's not a warm core structure, literally in any way, shape, or form. But what this feature does is that it helps to amplify the pattern in the Atlantic. Trigger number 2. So you have your pattern evolving. You're seeing how it's taking shape. You're seeing this feature over here getting ready to interact with these short waves. So it makes you pause. When you're seeing all these changes happening, and you're seeing a lot of cold air building in Canada, how about like minus 40 something degrees Celsius in northwestern Canada? What is more realistic? A warm weather pattern or a cold weather pattern? In other words, what has changed in the forecast to make you flip the pattern completely? And the answer is nothing. Now, what we have been seeing is that the long-range ensemble model guidance, right? That model guidance a week ago was very aggressive with the cold air. And I warned everyone, don't buy into the specific anomalies because they always overdo it. Whether it's heat or cold weather, everything's always -6 or +6. The warmest ever, coldest ever is extreme anomalies. Never buy into extreme anomalies until you're under 5 days out. Because extreme anomalies, usually, especially in ensemble guides, is driven by a couple of model runs that are completely unrealistic. But you could trust the overall theme, which is we're turning colder and stormier. So, when we start to set up this pattern, and let me pull up this feature here. And looking at the ensemble guidance, let's pull this in here. So what does this tell us here first, as we get just to 10 days out? Well, you have a moderate negative NAO pattern. And this is good news if you like winter storms, because you don't want a really super amped up historic negative NAO, because what that typically does is suppress the storm track down towards North Carolina. And while I'm sure people in Virginia would love to see a snowstorm, in fact, they pretty much jumped on that train a little bit too early, in my opinion, but you want a moderate to weak negative NAO for the northern mid-Atlantic, so you allow the storm track to get up to the coastal waters. Meanwhile, take a look what's happening in the Pacific here. Nice ridge here around Alaska. Why is this important? What we're establishing here with this block setting up is that you force all your Arctic air around Siberia to northern Canada, that cross-polar express. Well, that polar express is not just in the movies. It's actually something that we deal in meteorology, because that is going to drop into the plains and then spread to the east coast. So what you end up with is an active subtropical jet stream undercutting this ridge, sending short waves towards the mid-Atlantic coast under this block here, keeping cold air locked in. Now, we're not talking about historic cold, and here's an example. What I was talking about with the model guidance is that you get these extremes showing up in your model guidance, and people take this verbatim. So if it's not exactly minus 6 degrees below normal, there's some individuals and there's some people that believe that therefore it's a bust. When in reality, what you should be looking at this is saying, okay, the anomalies probably aren't realistic, but the theme is. And the theme matches up perfectly with a negative EPO pattern combined with a negative NAO pattern, which is basically you end up with your harder your cold air in the northern plains and the Rockies. You're talking about like highs in the teens and whatnot, and then your colder air spread out towards the mid-Atlantic, and your storm track cutting underneath this. So that's why you get your warm anomalies here, because your storm track is coming in from the subtropical jet stream and heading towards the mid-Atlantic coast. So to the south, you get your southerly winds, your rainfall and thunderstorms over the southeast, and your active winter weather for us. Now, that doesn't mean we're 100% certain to have a winter storm during this time period, because we don't know what the interaction will be with these individual short waves within this pattern. But the potential sure is high. Excuse me. And that's why I kind of had a good chuckle when certain individuals over the past couple of days were saying some insane stuff. So no, winter is definitely not canceled. The pattern is evolving at pretty much the pace I was expecting it to. The blocks are setting up the way I expected to, and more importantly, the observations are showing up the way I expected it to. So now that leads us to our winter weather threats. Now we have one for Friday into Saturday morning, which is more of an isolated rain snow shower. But the reason why I'm interested in this scenario here is because the 500 millibar pattern, which let me see here, I think it's this one right here. See this feature right here? See how it's diving around the ridge? That's very similar to what's setting up possibly for Sunday night and Monday. And the reason why I'm paying attention to this is that originally this shortwave was much stronger. So much stronger that it was producing a pretty good snowfall event for Virginia. Now that's pretty much shot, right? Because the shortwave is being sheared apart. So when we're looking at the next feature, which is for Sunday evening into Monday, this is the same type of scenario in which you have a short wave, this time a little bit deeper trough in the polar jet stream, interacting with this upper level low here, diving south and stretching the atmosphere. So this is a setup called an inverted trough. On one hand, you could see the lifting, you could see the potential, and the Canadian was very aggressive with this the past couple of days. That would support a moderate to heavy precipitation event, and yes, some of that would be snow. And what's very interesting is that at 850 millibars, we certainly have plenty of cold air to work with. The boundary layer temperatures during this time period are likely going to be above freezing on the coastal plain, but away from the coastal plain, we could be looking at accumulating snow. So why am I not putting out snow maps or anything of that nature? Well, I'm not convinced that this feature is as strong as what's being modeled. I'd like to see one or two more runs. Because when you have this feature here so strong and this feature diving under it, typically what happens is that this feature gets sheared apart. And so the stretching that's being shown here that supports heavy precipitation, you see how this is kind of spread out? It's kind of like, think of it like taffy. If you're pulling taffy and you get little rips in it, well, air is rapidly rising to fill in those holes. If this is overdone, then the precipitation potential is, reduced, and that doesn't lead to the solution that we're seeing here in the model guidance. This is much weaker then. So then the question is, are we dealing with a strong inverted trough with heavy precipitation, or is this more scattered? In which then we're talking about a dusting to maybe 1 or 2 inches over the interior, whereas this would be 2, 3, 4 inches of snow over the interior. And I would not be surprised if we get strong lifting if we get a rain-snow mix on the coast here. Because during this same time period at 114 hours, take a look at the 850 millibar temperatures during that time period. Plenty cold enough at 850. So the potential is there for our first real accumulating snowfall for the interior and some snowflakes, maybe a dusting or so on the coastal plain. But I want to wait until I get a better idea on the lifting parameters to really put out any type of precipitation map. Because otherwise, you're going to just be chasing the models and changing your forecast every 6 to 12 hours, which leads to more confusion than anything else. So yes, there's potential, but I wouldn't go beyond that. And then beyond that point, then we get our next feature. Now remember, a couple of days ago, this storm was phasing with the Arctic jet stream and leading to a huge upper level low that pulled up an air mass from Mexico right into our neck of the woods, and at the same time crushed the block that we have in the northern Atlantic and produced this ridge to reach all the way up towards northern Quebec. That's no longer in the cards anymore. So as a result, what you get is this vortex that is essential, because what this does is it carves out the polar jet stream, the trough, into the eastern United States. So we've gone from this, the southeast ridge, to this. Well, you have to do that. In order to do that, you have to have a storm, a very, very large, powerful storm, march through the Great Lakes and towards the Canadian Maritimes in order to set up that type of environment, which we do. And then that sets up your pattern evolution, where now you have a trough in the east, your subtropical jet stream remains active, and your polar jet stream starts to set up its block. And then you see how that evolves in the ensemble guidance. And oh, by the way, if you want to see whether or not there's agreement with that in the other model guidance, well, let's see here. Operational European, yep. We know about the EPS already. The GFS is all over. If you want to know volatility, this right here is a freaking mess. look at this. The range here in the GFS guidance is so extreme. It's the most extreme guidance I have, that you can't really trust the solution. If it wasn't for the fact that we have agreement from all the other guidance, I'd still throw out the GFS. And then you have the GFS ensembles, which right here. And you can see the same theme here. So what we have here is established a powerful negative EPO pattern, which basically means a lot of Arctic air is heading towards our neck of the woods. And how cold are we talking about? Well, let's pull up some guidance to really get a better idea on that, shall we? Let's see here. Reset. Go European. Go North America. And we'll do surface temperatures. So what are the surface temperatures being initialized at? How about -8, -10 degrees Celsius, -9 degrees Celsius, -22 degrees Celsius? I think this is kind of chilly. I'm sorry, Fahrenheit still. -10 degrees Fahrenheit, -28 degrees Fahrenheit. Very cold air is built up in Canada, ready to drop south. And if you want to know what that looks like in terms of lows, well, let's see. Talking about -20s, -30s. So yeah, plenty of cold air to work with in Canada. Plenty of potential. How that's all realized, we'll wait and see. But yeah, I don't know why there's some individuals saying that the winter pattern is going to be delayed or winter canceled or any of this other nonsense. Meteorologists are saying that, but the observations say otherwise. Now, don't be surprised going forward that you're going to see models flip and flop all over the place. But if you study the actual observations and understand what's happening in the atmosphere, then you won't have to chase the models every day and drive yourself nuts every 6 to 12 hours. So with that, I'm going to answer your questions. It looks like we're pretty active here on YouTube and also in the community chat. Of course, we'll start off with the community chat. YouTube, I pick the questions and see which ones I like. In the live chat here, in the premium chat, I answer all of them. So let's get this winter party started. Absolutely, Snow Boss. Okay, card axis. The polar vortex has major feeds from the tropic and mid-latitudes up to the poles. Even with the warping and splitting, feeds are going into both parts of the split at both levels. 10 millibars is so warped and 70 millibars is still hemispheric vortex. Even the strong part at 10 millibars is basically serving to take the warm air transport and speed and whip it around lesser rotation. So let's take a look at the environment at 70 millibars, because that really tells us a tale of what's going on in the troposphere. And you can see the split very clear. Okay, this is as disruptive as you could possibly get with the polar vortex. And you can see the influences of the atmosphere trying to balance itself out and what that is doing to the polar vortex. You can see the transport here taking shape from the tropics right into the polar vortex, that warm air transport. And at 10 millibars, you can see that warping continuing. So when we take a look at this and we see what's evolving here, what we can learn from this is, one, the idea of the GFS strengthening the polar vortex and basically consolidating it has failed epically. It wasn't even close. The European guidance was the closest to what's evolved here, which basically has severely disrupted polar vortex, some splitting, but even that one didn't accurately portray what's going on at 10 millibars and at 70 millibars, but it was close. The GFS and the GFS ensembles wasn't even close, period. So again, when you compare the observations to what's actually happening, unfortunately, and I don't want to say this, but take the GFS and throw it out. It just isn't performing. It was nowhere. If you look at the forecast for the stratospheric levels from 10 days ago till now, it's not even close. 10 days ago, the GFS had a strong polar vortex sitting right over Greenland. Now, nowhere near that. The European had a warped polar vortex that was a little bit stronger, but still clearly disrupted. And in reality, we have a split polar vortex. So the reality is a severely disrupted polar vortex, which wasn't handled by the model guidance at all, by the way. Feedback like not realizing a 50-50 low make it appear out of nowhere, right? Yes, feedback. That's a great example. The model guidance a couple of days ago and some of the snowier model guidance for the event for Saturday and Sunday, what it did is try to take this feature right here and make it into a monster upper level low, take this ridge and make it the strongest ridge ever over Greenland, and then force the storm to the south of us. So that was right about here. And the reality is that we're nowhere near that. But that's why when we see signals of historic heights and historic upper level lows, use extreme caution, because typically that's a sign of major feedback error. I think the reason so many people go crazy with models and model changes is because they have forgotten that models are simple tools, not at ends, that applies to all areas, not just meteorology. I think that there is some... Look, to someone who doesn't study this stuff, okay, who's just... They worry about other things. They got finances, whatever, okay? Maybe they're artists, whatever. I don't expect them to understand the nuances of models, why the forecast keeps changing and whatnot. So I don't expect it, but I expect it out of meteorologists, my fellow meteorologists. So I get a little bit more critical with that scenario, but I tend not to go after those forecasts because it's never good to go after someone else's forecast specifically without them being able to defend themselves. So I stay away from that because it just leads to more drama than anything else. Looks like the 250 millibar jet, that Pacific cross equatorial flow in both directions, is still there. Yep, it's still there. It's been years since there's been this much cold air from the surface up to 700 millibars in the northern hemisphere at this time. Yeah, it's been pretty impressive for December. Usually I see this build up in January, to be honest with you. Like December, we start to see the evolution and maybe some cold air focused over portions of Greenland and Siberia. But then it starts to build in Canada and we start to set up our weather pattern from there on out. This year it's happening about a month faster. So it's been pretty impressive, to say the least. Sounds like your prediction timing of phasing is going to present forecast issues all winter, even with favorable pattern. Yeah, as I've been saying since September, one of the primary issues going forward is going to be the phasing of the short waves and how they phase. So that's why I don't guarantee how much snow and all that stuff, because I know for a fact it's going to be a very difficult forecast. What flavor coffee? Tonight, French vanilla. So it's pretty good stuff. Here it was spiced gingerbread coffee. Well, not bad. Sounds interesting. Hello, Joshua. When do you expect Arctic air in the east? And any thoughts on the volcano that went off in Indonesia? Another volcano? I'm losing track of the volcanoes. We had a volcano go off in Indonesia now? I didn't know that. I'll have to figure that out. I honestly do not know anything new about a new volcano that went off in Indonesia. As far as Arctic air in the east, I would still like the end of this, like late December through early January as our first wave. Good evening, Robert. Mount Samir, if I recall correctly, only put. Oh, okay, all right, that one. So far, the volcanoes that have been erupting will not impact the global climate, okay? Because in Hawaii, and I guess this one in Indonesia there, yeah. I'm just taking a look at some of the data here, and it definitely, now it's not high enough. It's not high enough, and mostly what you're looking for in a volcano is a lot of ash and gases reaching the upper portions of the atmosphere, not the mid-levels. So this doesn't appear to be a strong enough eruption. The GFS upgrade a cell you off. Okay. Oh, okay. So the GFS that got upgraded, someone made an error and needs to go back and fix it. That's all I can say. Speaking locally, it's lazy meteorology. You can find a model solution to back any narrative you want. That is true. Local meteor forecast focus is the third La Nina, so any models that show that they go with so, and more so if it's extreme. I think that the focus of the quote-unquote third La Nina is going to be a major stumbling block. Because yes, it's the third La Nina, but there are so many other factors in the atmosphere that really doesn't factor into the other previous third La Nina patterns. And even those third La Nina patterns were not traditional La Nina patterns. So I don't understand the copy-paste idea of La Nina, especially since it's not that simple. You have east-based La Ninas, west-based La Ninas, weakening La Ninas, strengthening La Ninas. La Nina is not a copy. It's just a cookie cutter pattern. Just take copy paste and just repeat. But as I say, it is what it is. I can only do what I do. Most important news of the day: Yankees re-signed Judge. It was a smart thing to do. I think both teams are doing well with free agency, so it should be an interesting year, so to speak. So let's see what's going on in YouTube land. Let's see. Did you go to the freehold tree lighting? I did not. Honestly, I've lived here since I was a child, and I have not yet gone to the freehold tree lighting. That's sad. I know. We have to do that one day, but unfortunately, I have not. I don't know when it was. I didn't get it. Oh, now this. Okay. I gotta address this. Is the date still for December 14th for there to be a significant blizzard? How high are the chances? Okay, I want to know where you heard of December 14th and blizzard, because it sure as heck didn't come from me. Because I would never put a date on a blizzard, especially when there is no support for one. I did say that we'll see the pattern flip around December 15th, and that's exactly what we're seeing, and a cold weather pattern. Whoever told you about December 14th and blizzard, it didn't come from me, and you would have to ask them why they put that out. But it sure as heck didn't come from me. So maybe whoever's been saying that, maybe that is why we have this weird theme of winter delayed and stuff like that. Because that just didn't come from me. So, what about snow on Sunday? I think that for Sunday night, if you're north and west of the cities, I mean like parts of the Hudson River Valley, the Poconos, the Catskills, portions of Connecticut, especially just away from the coast, north of I-95, I think you guys have a pretty good shot at seeing accumulating snowfall. I just don't know how much yet. And the reason why I don't know is because I'm still skeptical of the lifting, as we were discussing. Along the coast, though, rain-snow mix. I don't expect much in the way of accumulation. I checked all the major sources, and there's no snow showing up for the next 2 weeks for central and northeast New Jersey. Just rain and temperatures in the 40s. That's straight. By the way, I just want to make that's straight GFS, and the GFS. That's why I wouldn't trust it. As far as snow potential, I think that you have a better chance in northeastern New Jersey than central New Jersey right now, climatologically speaking. What are your thoughts on the MJO? The MJO right now, that's a good question here. Let me bring this up because I talked about this in the long-range thoughts. The MJO forecast for the winter, in the winter forecast, specifically stated that for the most part it would be neutral and would not be a driving factor, but it would be a calling card. So when you're using the MJO, understand that it's not driving this pattern, and it's not significant in determining whether or not a pattern will be cold or warm or whatnot. And when you have this signal from all the guidance, in fact, let me refresh this just to make sure I got the latest. Okay, so what is the theme I'm seeing in all this guidance? Well, it's either saying that it's in the circle of death, which has no impact, or it is so weak that it doesn't have a sustained influence. See, like when it's just cropping out in here and here, it's incredibly weak. And there are other factors in the atmosphere that are far more important than the MJO. So, honestly, I really couldn't care what the MJO is saying right now. It's not important. Let's see here. Let's see. Robert would like to say hi to Susan. Hi, Susan.
Hello.
Agreed. Judge signing was a great start to the winter. Now bring the snow. I saw the pictures on Twitter and freehold lighting. Oh, cool. I have to see when those usually are. Speaking of dates, 18Z GFS looks interesting. Okay. I'm trying to stay away from the GFS, to be honest with you. And what else do we have here? I recall that in December 2019, an inverted trough brought 6 to 8 inches of snow in southern New Jersey. Yes, it did. Interesting that the one Sunday night might have synoptic upper level forcing with it, maybe some enhancement. See, the key with the stretching here, and let me see if I can pull up the right model guidance here. Here we are. Okay. You see this feature right here. The key here is Sunday night, right in this time period, right here, around 0Z. And you see this right here, at temperatures. You see that frontogenesis right here? What this is saying is that there's a strong stretching in the atmosphere. Now, the problem with this forecast this far out in terms of lifting parameters is that you have a stronger upper level low and stronger feature up here in the Canadian Maritimes. And typically, based on law of dynamics, the weaker feature, which would be the feature that would supposedly support the inverted trough, typically gets torn apart and gets crushed. So look at this feature back here. It's kind of like a huge wheel, and this is like a little rock. This rock most likely to get crushed, and so therefore the liftings to support it would be crushed. So I'm waiting to see whether or not that actually happens. Now, the way to prevent that from happening in the model guidance is if this feature stays far enough north that it guides this short wave through our area but doesn't crush it. So this feature has to stay back here. If it drops any further south, this is just going to get torn apart. So we have some time to watch to see how it takes shape, but I wouldn't jump the gun yet. Let's see here. We got more. Can you explain the difference, similarities between the EPO and PNA? Are they the same? They're within the same family. Let me see here. Okay. So let me go to 240 hours. Here we go. Okay. A negative EPO pattern supports a trough here in the Aleutians and a powerful ridge over Alaska into western North America, usually over western Canada. The PNA is a measure of the heights in the western United States for the most part. Now, the problem with the PNA is that if you have an active subtropical jet stream cutting under the large ridge here, you kind of get a muted effect. So you can end up with a negative PNA signal here, even though the influences are more of a positive PNA, because what you have here are two different jet stream features interacting over the region. So usually the EPO is driven primarily by what's going on in the polar jet stream. So you get a deep trough here around the Aleutians, a powerful ridge over Alaska. Arctic air gets shot down towards the plains. Usually what you end up with in this type of pattern is cold air first diving into the northern plains and then bleeding east. In a positive PNA pattern, what you end up with is you can get the same scenario here in the polar jet stream over Alaska and around the Aleutians, but you also get a strong ridge over the Rockies. The positive PNA signal usually features storm tracks where you get redevelopment off the mid-Atlantic coast and you get your nor'easters and your Miller A's and Miller B's. In this type of pattern with a negative EPO pattern, what you end up with are a lot of what's called panhandle hookers. And what that basically is a low pressure system developing around the Texas and Oklahoma panhandles that tracks towards the mid-Atlantic coast and cuts south. So those can lead to wintry mix events for the mid-Atlantic or significant snowfall events. But it's not a feature that basically redevelops off the North Carolina coast and tracks up through the coastal waters. This basically tracks across the Tennessee River Valley and towards the Delmarva Peninsula, and then you see what your impacts are from there. They tend to be fast-moving storms, and they tend to be moderate precipitation events. Sometimes snow, sometimes a wintry mix, depending on how the short waves interact. They both can be cold weather patterns, but they produce different types of storms. A positive PNA pattern supports low pressure systems out of the Gulf of Mexico or redeveloping off the North Carolina coast. They're what you call your Miller A and Miller B storms. The negative EPO pattern features storms that come out of the southern plains, usually driven by an active subtropical jet stream undercutting this ridge. But both can create pretty cold weather patterns. What do Friday evening and Saturday look like? Isolated, widely scattered rain, snow showers. Watch out for some slick roadways, but nothing too significant. Norland troughs. Well, let's put a pin on that for a minute before we dive into that. Is the pattern evolving like 95, 96? It's getting there. It's certainly getting there. I'm not saying we're there yet, but we're certainly moving in the right direction. When do you expect lake effect to pick up again? Basically, in the Great Lakes, let's see here. Obviously in the Great Lakes, duh. Let's see, when's our next cold air transport? Okay, so you'll probably see a nice shot coming in this weekend. And certainly continuing on. Anytime you get strong cold air transport, you're going to be in game for that. So probably this weekend, and then I'd definitely watch out for the end of next week into next weekend. Let's see. And let's see what's going on YouTube here. Do you expect the upcoming pattern past mid-month to produce winter weather events across the interior Northeast or the coastal plain? Possibly both. It just depends on how the shortwaves evolves. I wish I understood the weather, so thank you for what you bring to the table. Thank you. I try my best. But yeah, I think the pattern itself has a lot of potential. I keep on saying potential because I know that there's some individuals out there that make a lot of promises about winter storms, and they say definitely big wolf or barking noises or any of that stuff. The potential is there. I do not know the details or what that will lead to, but everything's on the table. One thing I am very confident in is that we won't see a sustained warm weather pattern out of this. That I'm very confident in. So let's see here. Not bad, 8:45. We're doing pretty good. Just taking a look to see if there's anything going on. Any of the observations here. Because I know, in terms of sports, I wonder how do Yankee fans feel with all the nonsense that was going around, saying that he was going to the Giants and freaking everyone out, and apparently that didn't go over so well. Let's see. Okay. So far, data looks pretty good. Let's take a look at our observations. Our cold front's starting to sink through. There's our cold air transport starting to push in. And overall, I mean, here, let's pull up the GFS because some people are bringing it up already. So might as well take a look and see what is the wacky GFS doing these days here. Let's see here. We'll start off with the surface and see why everyone's all excited. Do you think Christmas Day will be cold? I have no idea. There's a good chance, but I don't know specifically. I mean, here's the problem with that forecast, right? You could have, in the model guidance, like the long-range model guidance, it obviously has below normal temperatures. But once you get close to that, let's say you have a clipper that's approaching the region, and you're on the warm side. So you're 45, which is pretty much near normal for Christmas Day. And then Christmas night, the low pressure system moves through, and then we get snow. Now, technically, Christmas Day is slightly above normal, but Christmas night, you end up with snow, so people are happy. So you get a slight difference in that, and it's not exactly an accurate forecast, so it's always tricky. Let's see what the GFS is doing. Well, the GFS now looks very similar to the European and the Canadian. How do you like that? Nice little inverted trough there. Nice little feature, and then on Monday morning, changing over to snow, even down towards the coastal plain. So yeah, it's definitely something to watch. And then the GFS is looking, the 18Z GFS is looking very similar to what is going on in the European guidance. And then, now I see why people are getting a little excited here. Well, that would do it. Okay, so here's a question. Is this solution reasonable? Well, let's see how it produces these service solutions. Because on the surface, is it a reasonable solution what's being shown in the guidance? And it's within the potential solutions that this pattern would produce. But let's see what it looks like at 500 millibars. Well, there's that short wave for Saturday. Look, it's getting sheared apart. Then we have the Sunday short wave. Now this is interesting. The GFS on here keeps this as an upper level low, which enhances the precipitation, cools the atmosphere, and that's how you end up with snow down to the coastal plain. And we have our upper level low, cold air. Now here comes our storm that carves out our new trough, locks everything in. You get your blocking all set up, and there's your short waves from the subtropical jet stream undercutting the negative EPO NAO pattern. But of course, this feature, of course, you're talking 15 days out. When you get this type of signal here, this usually leads to a more of an eastward type of low pressure system track, but a lot can change here. But what's the overall theme? Ridge in the west, trough in the east, cold air building in. And do we have plenty of cold air to play with? Let's see. What are we dealing with cold air on here? If I can find it. There it is. Well, the GFS is starting to pick up on the cold air. Well, that's certainly some good news. And hey, remember all that Arctic air I was talking about that was building up there? Well, there it is. Building in, locking in, reloading, getting ready to drop in again. So, I wouldn't use the GFS for a forecast, but I would say it's at least back in the realm of reality. I'll put it that way. Let's see here. GFS has over a foot of snow through 384 hours at 18Z. Let's see here. What exactly is an inverted trough? Okay. An inverted trough. How do I explain this simply? Okay. An inverted trough is a scenario where you have two areas of closed low pressure systems, usually around the coastal plain and over the interior. And what's happening in the atmosphere, and let me go to 108 hours again and zoom in. You have strong lifting here. You see how this is kind of all spread out here? And you have your upper level low back here. So you're having rapidly rising air here and rapidly rising air here. Now, this feature is blocked from leaving the region because of this upper level low here. So what you end up with is a lot of stretching and pulling in the atmosphere, which leads to below normal heights setting up over the region. So you have crashing 500 millibar heights, rapidly rising air, and a lot of pulling in the atmosphere, which leads to a displacement of mass. And so what you end up with is this trough of lower pressure and rising air. Now, typically in a trough, you have everything moving from west to east. But the lifting in an inverted trough is from southeast to northwest. And it intensifies as the stretching in the atmosphere continues. Inverted troughs are a nightmare to forecast for because a slight deviation in the lifting parameters could lead to rapid cooling of the boundary layer, i.e. the coast, and could change a rain event into a snow event very easily. So you have to watch it very carefully. But on the flip side, if you don't get this perfect stretching environment, then the forecast lifting basically falls apart. And you end up going from a forecast where you have significant precipitation to barely anything. So it's kind of an all or nothing type scenario here. So you have to watch out for that very, very carefully. Let's see here. Let's see. Give us Final Genesis. Nolan was the man. Yeah. So you can see what the environment we're dealing with here in this setup. Now the GFS, let's see here. I'm curious to see what the GFS looks like at 500 millibars. Let me pull that up during that time period. Now again, the European looks like this. And this is at 0Z Monday. So that's about 7 p.m. Sunday. So let's see what that looks like. Pull up the right guidance here. Here we are. Okay. So the GFS has the upper level low over northeastern Pennsylvania. It has your strong lifting here, but notice it's not as spread out. Very strong lifting along the Jersey Shore. This would cool the boundary layer a lot faster. Your stronger lifting is focused more so towards northeastern Pennsylvania rather than the Hudson River Valley in Connecticut. Interesting diffluence setting up over New York City. And this feature is much stronger, but here's a warning sign. You see this feature right here? This typically means that this is starting to get crushed. So, certainly a lot of interesting features showing up in this guidance. I would say give it 24 hours. Tomorrow evening at this time, we should have a much better idea of what we're dealing with here. Because by then, we should get a better idea of what type of blocking patterns we're actually dealing with. So, I'm going to hold off on any projections of snowfall and whatnot until, at least for premium members, until tomorrow. I'll start making some of those adjustments. And then for the public, if we're at that point, those would come out on Friday afternoon or evening, depending on the guidance that I'm seeing. So then we'll work on that and see how that sets up. What are the water temperatures these days and how will they affect the precipitation type? Water temperatures, let me see here. I believe they're still running above normal, but let me pull up the Northern Atlantic. Yeah, we're still well above normal. And let's see here. And we're running about, let's see here, about 10 to 12 degrees Celsius, which is typical for this time of year. Let's see if I can pull in this. Okay, so this is a really important signal here. I'm probably going to close off on this for the night because then I'm going to shut it down. Why is this important? Well, if we're pulling in polar and Arctic air masses towards the coastal plain, so we have this signal showing up. If I can pull up the right one. There we go. So we're having this signal showing up, right? Where we have this cold air getting pulled towards the coastal plain. And then you have this warm water setting up off the east coast. What this sets up is the potential for strong cyclogenesis, especially with our Gulf Stream, which is right here. What this signal will do is that when polar and Arctic air masses reaches our region, it can amplify low pressure systems and certain troughs, by the way. In terms of precipitation impacts, precipitation type, that's a little bit more complicated because on one hand, if you get a straight easterly wind, it'll take the warm environment and drive it into the coastal plain and change everything over to rain. However, if you get a low pressure system rapidly intensifying with a northeasterly wind pulling in the colder air mass from New England into our neck of the woods, then what that does is that enhances the frontogenesis over the region, enhances rising air, which in turn enhances precipitation rates, cools the boundary layer, and produces heavy frozen precipitation. So it just kind of depends on what the factors are involved in each scenario. If you have a low pressure system passing through the Delmarva Peninsula and a high pressure system is exiting into the Canadian Maritimes and you get an easterly wind, basically you'll be around 50 degrees in no time. But if you have a strong low pressure system marching off the Delmarva Peninsula, high pressure locked in over Maine or New Hampshire, and cold air is funneling down the coastal plain, funneling towards the low pressure system, this feature, then that feature interacts with all this warm water. The Arctic air is coming in behind it. That intensifies the low pressure system, and you get a very heavy precipitation event right here. So the devil is always in the details. So you can never just say blanket one statement. You always have to consider all factors involved in that scenario. Let's see. So that is our discussion for today. If you're interested more in what to expect with the negative EPO pattern and the pattern overall, definitely check out the Premium Consultant discussions. All you premium members, you know what I'm talking about. Where the past couple of days, while everyone else is running around with their head cut off, screaming, blizzard, no blizzard, winter canceled, winter here, blah, 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 we've been consistent with the same message and the same data. So if you want to get data and information that's consistent, level-headed, and logical, definitely check out the Premium Consulting membership, only $11 a month or $8 a year. That is it for tonight. Thank you, as always, for visiting and dropping in. All I could say is I think we're going to be pretty active moving forward over the next couple of weeks. I don't know the details, but I know I'm going to be busy. And I think I'm going to need to go buy more coffee. Yeah. Have a great night, everyone. And as always, stay safe out there.